Hey y'all, welcome back. Good to see you back again. Hope you're all well. Today on my bench I have a Hafler DH220 power amplifier. This is a stereo amplifier, 115 watts per channel, bridgeable. It's got some good specs. The story behind this, this came from a local friend of mine. He, I don't know, he's owned it for a while, and I guess it had some problems. He went into the amplifier and changed a few capacitors that were bad, and he replaced a few resistors that looked iffy, that didn't look quite right to him. And then he put it all back into service. I guess before that it was making a distortion. It wasn't clean. And then after he did the repair, it sounded okay. It sounded good. And he was listening to it for a couple hours, and then there was smoke coming out from the top, I guess. I don't know. I think he looked inside. He didn't see anything obvious, but he shut it down and hasn't powered it up since, I don't believe. And he brought it to me to go over it, make sure it's 100%, and see if it's, if it's got any faults, just to deal with it. It's interesting. This is a MOSFET amp. It's got, let's see here on the schematic. On the outputs, it has tandem MOSFETs on the outputs, and they are, I believe, 2SK134s, 2SJ49s. So you got N channel and P channel, which are probably getting close to impossible to find nowadays. I think you can find them on eBay, but you're going to pay, a good price, and then you don't even know if it's a counterfeit or if it's legitimate. And so I'm hoping these MOSFETs are okay. I kind of suspect, well, I don't know what to suspect at this point, but if something was smoking and burning, it's probably a resistor, not a transistor. So we might have to go in and do some checks and make sure everything's okay. But we'll do that. So let's open this up, have a look inside, and see what we can find. Oh, let's look at the back first. So on the front, it's just got a power switch, illuminated. This thing is heavy. On the back, it's got two speaker fuses, and they are supposed to be 7 amps max. What is this? 5. And 5 amps. Okay. So they're intact. We got our 2 inputs and our speaker output. And that's it. Alright, so we're in. Looking at the inside of this amplifier. Everything looks okay. It looks to me like this thing has been factory assembled. Just judging from the soldering job on the printed circuit boards, it looks like it's all been reflowed. This isn't hand soldered, that's for sure. So I think we have a factory build here, and everything looks good. I did notice right off the bat, if you can see this, there's one fuse here is gone. These two fuses would be for the positive negative rails for the amplifier. There's one on each side. Here's another positive negative fuse. Those two look intact. This one, actually they're both gone. They're both blown. So we might have shorted outputs on this. This is not looking good at this point. So let's see. Yeah, we got two fuses on this channel here that are gone. So and we'll be disassembling this side for sure, taking a look at it. And I can see, I don't know, I don't see where I can see a couple of capacitors that have been changed. But we'll get more into it here. I'm going to disassemble this amplifier on this side, remove it from the chassis. Alrighty, we got the amplifier out of the chassis. Let's take it out of the, separate the board from the heatsink, and we'll check these MOSFETs. I hope they're not shorted, because that could be a deal breaker here. And I don't have an access to replacements. I don't even know where to start for replacements. And I don't pretend to be any expert on MOSFET amplifiers. Okay, you can see on the board, it looks like it's all been flow soldered, and it's very clean looking, but then there's the spots where a few things have been replaced, and here's a problem right here. This joint here is not even soldered. That goes to a capacitor, I think. Yeah, that's this capacitor here. It is not soldered, and this one's not soldered either, and that goes to a resistor. Okay, so we're on to something here. Surprising it worked at all, considering these two joints weren't soldered. And these ones are soldered, these ones are okay. Everything else looks okay. Alright, so let's check our MOSFETs out. How do we check them? Well, I'm just going to check them for dead shorts. The red wire and the white wire would be your drain and source. And then the wire with the resistor, I think, is your gate. Because it's okay, so let's just go here, and we got it on dial check. These little washers I should keep. And what do we got here? I don't know if that's good or not. I'm assuming that it is, because it's not a dead short. Let's check this side. Not a dead short. These two transistors are wired in parallel, and these two transistors are wired in parallel. So let's check between the gate and the drain and source for any kind of a short. There's no shorts here. Okay. Doesn't appear to be any shorts there. It's all looking good so far, I hope. Okay. So the only one reading that was really low was this one here. It's coming back at 150 millivolts. And that is between the red, which is B+, and that, which is your speaker output. Let me take these two transistors out, and then we'll test them individually. Might be better to do it that way instead of testing them in parallel. Okay. So we need, between the case it's open. Okay, I turned it on by touching the gate. Now if I short the gate, it should be open. Come on. Okay. If I short the gate, it should just charge and it should be open. Okay. Maybe it is working. Let's hope it is. But those two components that aren't soldered to the board, this is definitely a problem. I don't know. We're going to have to go through and check all these transistors because there's something suspect here. So let's do that right now. We might have more going on here. Let's see. Where's the drivers? The drivers are here. Let's check these drivers. That one's good. That one's good. This is looking promising. Is that all that's wrong with this? Is there's two solder joints that weren't soldered? Let's check this one. That one's good. It's good. And the other one on the other side. Good. So the drivers are good. Okay, let's try. Okay, no shorts there. No shorts there. This one looks funny. This one's suspect. That one's okay. 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 Might be a PMP. Good. 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 Everything's checking out here. I'll go on to the diodes after. Good. Everything looks all right. Let's check the diodes. Did I miss any? Oh yeah, here's one buried. I can't see it. That one's good. Alright, everything's checking out except for that one transistor suspect. I'm going to pull this transistor and test it. Alright, so here's a little test for a MOSFET insulated gate. This is the 2SK134 made by Hitachi. And you connect up a power supply. This here I'm supplying roughly 5 or 6 volts. Positive, going through a light bulb, going to the transistor, and through the transistor to ground. So to turn the transistor on, all you need to do is, I got a 2.7K resistor here, and I just grabbed any value out of my parts bin. So I'm going to touch between the positive and the gate, and the transistor turns on. It latches on because what I did is I charged the gate with the 5 or 6 volts through this resistor. Now if I discharge the gate, because it's got a capacitance, right? It's got a very tiny capacitance. If I discharge it with this resistor, the transistor shuts off. This transistor is 100% working, so let's move on and do the other ones. So here's the other N channel MOSFET. I'll just connect the wires up. And the transistor's off, as you can see. And let's try this test on this transistor. Turns on, turns off. Okay, that transistor is good as well. So both N-channel transistors are good. Let's try the P-channel ones. So for the P-channel transistors, what I'm going to do is I am going to swap positive for negative. We're going to do the same thing, but it's going to be in reverse. So let's turn this one on. Transistor's turned on. Turn it off. Okay, yeah, it's working. That one's good as well. Okay. Oops, wrong pin. There we go. Yeah, all 4 transistors are working. So I'll reinstall them. It's looking pretty promising at this point. It looks like I tested the transistor. Where is it? The 2N220, 2222, and it tests fine. So I think we're going to be okay. I think if I reassemble and resolder those 2 joints that weren't soldered, we should be able to power it up and check and see if the amp comes alive and we don't have any faults. Alright, so stand by. Alright, now I got the MOSFETs reinstalled. I'm going to check to make sure there's no shorts between the transistor case and the heatsink, and just put it on continuity mode. Why is it making any noise? There we go. Maybe it's time for a new meter. Alright, I think next step is put the transistor back in, resolder those 2 joints that weren't done. These are the 2 capacitors he replaced. I don't understand why he replaced them, but they're good Nichicons. I'm just going to leave that alone. And I think it might be time to power it up and test it. Actually, before we put power to this, I'm going to go through and I'm going to ohm out all these resistors, make sure we don't have any surprises, any opens or anything like that. They all look good. For example, these are 47 ohms, 52 ohms. That's not good. 47 here, 52 ohms. R32, R31. R32, R31, 47 ohms, quarter watt carbon comps. And they're 5% tolerance, so they shouldn't be that far out. Maybe I'll replace those. Why not, eh? They're carbon comps. They are more than 5 ohms out, which is outside of the 5% tolerance. So I'm going to change those two resistors. Okay, we got everything reassembled and put back in. And part of the assembly instructions when you finish assembly is you place one fuse in the negative rail, 5 amp fuse, and in the positive rail you put an ammeter, and what you do is you power it on and you set this ammeter for 275 milliamps using the bias adjust. So that's how you set up the bias on this amplifier, is you measure the current draw, idle current draw of the amplifier, and you adjust it that way. So we're going to try that right now. I have it all connected. I have an ammeter, and I hope I don't blow up my meter. If I do, it, well, I'll pop a fuse before anything else. So I have this. So let's give it a try, I guess. Get this out of the way. I don't want that shorting on anything. Turn this on. Okay, it's way over 300 milliamps. So let's turn this down. $275 milliamps is the point directly between 2.5 and 3. So let's see if I can get this. It's pretty close right now. It's about 270. Turn it up a little more. Right there. Should be good. Okay. Now I also pulled the fuses from the other channel because I don't want this to power up. I'm going to still check this over, make sure everything 100%. I'm going to let that sit for a while, power it on, and I'm going to see if that current climbs or drops or does whatever. But it seems like it's behaving properly right now and it's working. Turn it down a little bit. Yeah, I'll just let this idle and let things warm up. Another thing I need to do is I need to check DC offset on the speakers. So let's do that right now. I got another meter here. And let's check the voltage. Yeah, we're way out. Look at this, 170. Okay, let's adjust that while we're here. Oh, this is a really messed up pot. Okay, right about there. I think they said within 10 millivolts, but I'm going to leave it like that for now. I don't know why it's so twitchy. Okay, I'll just let this idle for 20 minutes or so, see how it works. If anything heats up, maybe I should get my blur out and have a look at it. Alright, so it's been on about 15-20 minutes now, and the current has actually dropped. It is now down below 260 milliamps, and the offset actually went up to about 50 millivolts. So let's just tweak this one more time, and then I'll call it done. It's getting a little warm. It's barely warm at all. It's idling nice. The watt meter shows 44 watts, and I only got the one amplifier live right now. This one's dead, but that seems like a little excessive, especially for idle current. But we'll turn this down for the offset voltage, or the output voltage, the DC offset. Let's turn this down a little bit. Try and get this close to 0 as I can. It seems it wants to drift anyway, so I think that's going to be good there. And then we'll turn this one up a little, get it back to 275. Our current consumption went up to 45 watts. Okay. Alright, I'm going to shut this off, and we're going to do the other channel. I'm going to go check it out, make sure there's no bad connections, and we'll do the biasing and setup on that channel as well, and make sure it's all good. Then we'll do a power test. Alright, just a little look at the schematic here and what I found with this amplifier. On the left channel, we're looking at the right channel here, but they're both identical. On the left channel, I found two solder joints that were not completed. That was R25, which is right here. R25 is a 33K resistor, and it is right smack in the middle of the feedback loop. Now, there's other resistors with capacitors. There's another resistor here, R26. R25, yeah, R25 is directly in the feedback loop, the DC loop of it. R26 is like it's got capacitors in series with it, so it's got some frequency characteristics. And same as R27, it's got a capacitor. So R25 probably sets the negative feedback, and if that was open, I can see how that could be catastrophic to the amplifier. It would be running full gain. Yeah, so I can imagine it would do some damage. This other capacitor, C7, was open. That was the other one component that wasn't soldered, C7. And like I said, that's in the feedback loop again, but that one's not detrimental. I think that's more of a frequency dependent component. And also R31, R32, these are 47 ohm quarter watt carbon composition resistors. I don't know why David Hafler specified carbon composition. What I did is these measured way out of tolerance, these two. Carbon comps are notorious for going off tolerance, or off value, going outside of tolerance. So what I did is I replaced these with the correct value, because they measured up around 51, 52, some were, I think one was 54 ohms. So I put in 47 ohm resistors, and I put fusible resistors in both positions. The reason, because these two resistors supply everything on the left hand side of this amplifier with power. All the power is fed through those two resistors for powering this part of the circuit. And if these are low or high in value, then you won't be getting the proper voltages, I don't think. It worked, but I don't think it's right. So it was out of tolerance. I changed it. Yeah, we went through and checked all the MOSFETs on the left channel. They were all good, and these two fuses were blowing. That kind of makes me wonder what happened to make those two fuses. They weren't blowing hard like a dead short. They were blowing like an overload, a small overload, because they just opened. They didn't arc and flash. So maybe this was driven beyond what was intended. I did notice the bias settings were turned way up on both channels. It was way up over 300, maybe 325, 350. So these transistors were biased on hard, and I think they might have got hot, and maybe we had some thermal runaway. But if it was designed properly, like it looks like it was, it just opened those fuses, and everything was good. Alright, so we're all wired in for initial power test here. I got my typical 8 ohm load, feeding with 1000 hertz tone, and we got the scope up so we can see what's going on with the output. We got a voltmeter here hooked up as well, so we can monitor the power output. So let's turn this up, turn up the signal, and let's see how this is going to work. If we got any distortion or any bad stuff happening here. Just keep turning it up. I think I need to Ooh, this thing's... This keeps going and going. Let's see how we can... Alright. Let's just keep going until we get clipping. Right there. Yes, we have clipping at, we have 35.33 volts RMS. I'm just going to let this go for a while and see how things pan out. A little bit of electric shock there if you touch that, because we're dealing with some pretty high voltages. These heat sinks have a lot of mass to them, so they take a while to heat up. It's all cast. I don't think it's extruded, I think it's cast. Maybe it is extruded. No, I don't think so. But we got equal amplitude in both channels. We got no distortion. Everything looks good. So yeah, that's hot. Okay, we don't need to cook it that long. Let's turn this down. We're at 4.99 volts input, and we're at maximum output. Let's start to smell things warming up. Let's turn this down. Yeah, this thing is cooking. So no, we're doing pretty good here. I think we're good to go. Close this up. It's all been adjusted, set up. The biasing, the DC offset. I'll test it one more time, just to make sure it's good before it goes out the door. But I think we're good to button this one up and call her a day. Well, there we go. We're done. All back together. Total parts count: 2 blown fuses and 4 out of tolerance spec resistors. So this one's ready to go back to its owner. I'll give him a call. I'm sure he's going to be happy to see this one again. Thanks again for watching, and hope to see you on the next one. Take care.